ladies and gentlemen, on this Tuesday, May the 5th. Hope you're all doing very well. I've got a kitty cat on my lap, so I'm doing quite great. Today we're going to continue talking about probability, and we're going to cover a major probability basic, or fundamental, I suppose would be the better word. We're going to talk about two things called unions and intersections, and the main rule that involves them. So, an intersection, I might have seen a little bit about it yesterday in that one problem. The probability of A intersect B, which means A and B, where you have both the event A and the event B happening at the same time, or things being simultaneous. Now, an example of this might be people who play sports. Like, I know a few of my students who play both basketball and football. So, having the probability of having a student who plays both basketball and football could be very high. Or someone who is on the gymnastics team and plays volleyball. That could also be pretty good, but that would be an intersection of two things. I consider a good analogy for an intersection is literally an intersection of a street. Suppose you have two streets. You've got street A going down like this, and there goes the kitty cat. And suppose you have street B going like this. Well, what do you call this little block right here? It's literally the intersection, because it is both street A and street B. Alright. The intersections are often countered by what we call unions. Unions are not intersections, as we can see from the other symbol, this U that we have here. And an intersection is something that is A or B. It can happen simultaneously, it can, but it doesn't have to be. It could be having something like, alright, let's consider days of the week, like we did yesterday. Now, if I want to say something like, oh, let's consider days that begin with T. Well, days that begin with T don't necessarily have to be the same thing. They can be both Thursday or Tuesday. They're not the same thing, and definitely can't be the same thing, because if you are on Thursday, you definitely can't be on Tuesday. But the rule that we have behind them is that the probability of the union of A and B, probability of A or B, is equal to the probability of A times plus not times, plus the probability of B minus the probability of A intersection B. Now let me get a Venn diagram on this. Let's say this is A, let's say this is B, and if we want to figure out what the probability of A union B, that's going to be everything in A, right? Everything in A. So that includes all of this and all of this in the middle, because that's both A. Well, then we also have to consider the probability of B. If I consider everything in B, I get everything here, but also in the middle. So that's why I have to take everything out of the middle, or subtract everything in the middle, because I've technically already counted it. And if I include it again, I'm going to be double counting. and that's going to throw your numbers off. It's going to throw your probabilities off. So that's why I can't, if I include A and B, I have to get rid of that middle, at least numerically. So let's see an example of this. The probability of A intersect A union B is 0.95. The probability of A is 0.75, and the probability of B is 0.6. What's the intersection? Well, at this point, let's just fill these in. I mean, we have all our values. Let's just substitute them in. A union B. Well, that's 0.95. Probability of A is 0.75. Probability of B is 0.6. Well, then, guess what? We just get rid of A. We have to get rid of this portion. Well, what's 0.75? What's 0.75 plus 0.6? Well, that is 1. That's 1.35. If my math serves me correct. Oh, there's a cat hair on the mouse, so therefore it wasn't writing correctly. That's funny. Alright. Alright. Well then, you subtract this value on both sides. So minus 1.35, and 0.95 minus 1.35 should be negative 0.4 if my mind serves me correct. Yeah. Is equal to the negative probability of A intersect B. Well, guess what? You get rid of the negatives. 0.4 is equal to the intersection. And so the way we would see this is that if 0.4 is equal to the value of the intersection, then that is what is in both A and B, and therefore we had to remove it so it doesn't go over 1, as we saw there. Alright, work this problem on your own. The probability of A union B is equal to the probability of A plus the probability of B minus the intersection. But the intersection is 0.45, A is 0.5, and the union is 0.55. You want to figure out what the probability of B is. One of my cats is being rambunctious. She wants to play. But as we did last time, let's just put in values. We can do basic substitution, we can do basic addition, it doesn't matter. Probability. I've gotten a little backwards on this notation. Minus 0.45. Well, combine your like terms. Well, I've got a 0.5 minus a 0.45 is equal to a 0.55. So 0.55 is equal to 0.05, because 50 minus 0.45 is 0.05, obviously. Well, 0.55 minus 0.5 is 0.50. That's the probability of B. Now you might say, hey, wait a second. That's what the value of A was. How can it be the value of A how can it be the value of B if it's the value of A? Well, that doesn't mean anything. I mean, two different events can share the same probability, and they could have the same thing occurring, especially if the chances of them overlapping is 0.45, or the chance of them both occurring is a 45%. And I do remember 0.5 is the same thing as 50%. Alright, we got about 5 minutes. Let's finish on this last part. Now, empirical probability, that's probability that just uses actual context, like actual numbers or actual statistics or actual characters. Now, in a hospital unit, there are 8 nurses and 5 doctors, 6 nurses and 3 of the doctors are females. If the staff person is selected, find the probability that the subject is a nurse or a male. So what we're trying to do is find the probability if someone's a nurse or that they're male. We're trying to find the probability that they're none. But 2 ways you could do this. A, you could work it like we just worked it, and it would be good, but you might be super careful on trying to find your individual probabilities. Because if you want to figure out, okay, what's the probability that someone is a nurse? Well, how many nurses are there? There are 8 nurses out of 13. So the probability that someone is a nurse is going to be 8 out of 13. What's the probability that someone is male? Well, they don't tell us that, but they do say that out of the 13 that there are, 9 of them are female. So what's 13 minus 9? Yes, okay, I did that right. Probability that they're male is 4. Now you want to figure out how many of them are both male and both male, not male and female, both male and a nurse. So the probability of intersection. The probability of NAM. Alright, well, if there are 4 males and, well, there's 8 nurses and 6 of them are female, how many have to be male? 2. So if you add that all up, 8 plus 4 is 12, minus 2 is 10. Yep. Now the other way I would recommend doing this is build a little box. If you know what your values are, and except you're worried about what those things are going to be, well, you can always build a box. So let's say this is nurses, and those are doctors, and those are female, and those are male. Well, how many female nurses are there? There's 6. How many female doctors are there? There's 3. And by contrast, well, if we know that this is a total and that is a total, and we know that there has to be 13 of them, well, and that there has to be 8 nurses, because we know that there's 8 nurses, and we know that there has to be 5 doctors, well, 2, 9, and 4. Well, guess what? How many males are there? 4 males. How many nurses are there? 8 nurses. How many male nurses are there? 2. And so you can just pull those numbers and you can fill them in right in here and do the same amount. Now if you don't need to build this chart, just immediately go into that. It's totally fine and it's totally doable. But if you do need to build a chart, it's pretty easy and you can just do it right there. Now we are super short on time. And so what I'm going to do is I'm going to build a chart and I'm going to give you the answer on this one. You have to make the connection. So on New Year's Eve, the probability of a person driving while intoxicated is 0.32. Ladies and gentlemen, do not drink and drive. The probability of a person having a driving accident is 0.09. The probability that the person having a driving accident while intoxicated is 0.06. So, if I wanted to figure this out, what's the probability of a person a person driving while intoxicated or having a driving accident. You want to find out what is the probability of accident or drunk. Well, you've got to figure out the probability of having an accident, a probability of someone being drunk. Drunk, not drunk, accident, no accident. Well, probability of someone driving while intoxicated is 0.32. The probability of someone having an accident is 0.09. 0.09. And the probability of a person driving having an accident is 0.06. Well, guess what? This is literally all you need to solve this problem, because if these things add up to 0.32, and you know that's a 0.06, well, that means this. What is 0.32 minus 0.06? 0.26. Well, that means it's a 0.03. Hope I had that. I apologize, my brain stopped for a moment. I might actually have to go back and take a look at this one, because what you need to figure out is, anyways, the answer to this one was going to be a 0.35, but I'm going to come back and check this one out. Ladies and gentlemen, have yourself a great Cinco de Mayo, May the 5th, Free Taco Tuesday, if that's what your thing is. Ladies and gentlemen, have yourself a great day.